Okay, you don't want to miss this next talk. We've got Timoni from Unity. She runs the XR team, interdisciplinary artists, coders, developers, and dreamers down in San Francisco for Unity. So I'd like to introduce Timoni and bring her on stage.
Hi, everybody. Thanks for being here. I know it's afternoon. It's exactly in time when you want to go get some coffee. So if you want to go run out and get some, no worries. As I was introduced, I'm Timoni West. I am the director of XR research at Unity Labs. And today I'm going to be talking about the tools that we are making in labs and trends we are seeing across the board for spatial computing as a whole. I'm going to start off with this video that shows a little bit of the projects that we're working on. Is there sound by chance that we could play right now? This is just our sizzle reel of projects that we're working on across labs today. We're working on more than XR, so it'll show you a taste of what we're doing. Any sound? I can hear it, but it's really quiet. I could just hum. Yes, no? We can just move along if we need to. It's okay. I also have a slide. We can just do this. That's cool. All right, we'll skip the video for now, unfortunately. But these are the different projects that we've been working on in 2018 in labs. So we have ontological metadata for semantic creation, otherwise known as smart assets, assets that have certain properties and know about themselves. Authoring tools for spatial computing, that's my group, and I'll talk more about that. Graphics research, obviously Unity is always trying to push the bounds of what we can do. Human capture and rendering, trying to make humans look as good as possible, the ultimate holy grail, especially for real-time rendering. And then artificial intelligence for NPCs, which includes behavior planning, so you can set up a tree of behaviors for your NPC, so they behave in a more realistic way. And then also animation planning, which has similar properties. Okay, so in my group, one of the first things that we tried to tackle was how to take this interface, which is a pretty conventional way of dealing with 3D objects in a 2D plane, where you've got just sort of your typical manipulator, and then putting that into 3D, what we call 3D in 3D tools. So this is an example of Editor XR, which is the tool that came out of that. And Editor XR allows you to be in the headset, actually in edit mode in Unity, editing your scene. And we thought that this would be really easy and really intuitive and everyone would get it because we live in a 3D world. And it actually turned out to be tremendously challenging and we had to do all sorts of weird things we never thought we'd have to do. This is an example of something we call the mini-map. And the mini-map lets you see the scene that you're in on any size at any scale and actually pull out objects and move them in between different parts of the scene. And this is kind of the equivalent of if you have different windows open in your applications where you've got one on one part of the, one camera on one part of the view and another camera on another part of the view. But we had to do a lot of things like this that we weren't expecting. Because it turns out when you're in a life-size space that is an enormous world, you need lots of different ways of moving things around quickly. Things that are full size are sometimes too large to move effectively in a way that makes sense. Because in the real world, obviously, you can't pick up an entire building and move it an inch efficiently. We just don't work that way. So that's a good example of a really custom tool that we had to make that has some parallels to conventional 2D computing, but that we hadn't expected to have to make in the first place. This is a sneak peek of a new interface that we're making that allows you to have gaze-based UI. So I might want to try to back this up a little bit. Okay, cool. So here you are back in Editor XR. We have an annotation tool that you can draw with. Actually, you know what? I'm sorry. I normally ask this first, but since we skipped the video, I forgot. How many people in this room know what Unity is? Okay, everyone. Great. Sometimes it's like 2 people, and then I have to go and explain everything. But good, this is great. Like, I think that was 90% of the room. OK. For the 10% of you, it's a game engine. You already saw what it looks like. We're trying to put it in VR and AR as much as we can. OK, so this new interface, I think, is particularly interesting because a lot of the UI that you may have tried if you have used like a VR creation tool tends to be tied to the controllers. So if you're in Tilt Brush, for example, or Medium, you'll have a palette that's sort of attached to one hand. And Tilt Brush does have ways now to pin UI in space, But we thought we would take it a little bit further and actually have the UI appear where you're looking and then quickly disappear. So the way this works is if you hold down the secondary grip or the controller secondary trigger on a touch, it just will pop up a UI, and you can just, from any vector, move your hand to quickly scroll through available options. So here he's looking up at the ceiling, actions comes up, and he pulls up his hand and chooses to move to the selection tool. And now he's going back to, I think, the create primitive tool, so that palette opens up, and he can draw, I think, a plane here, I don't know, cylinder. But the idea here is that often what you're looking at is where you want to be. And if you have to continually move your head more than a certain amount of degrees or a certain amount of angles, it gets not only tedious, but then it's very hard to find where you were before and get back in the groove. So we're trying to create as much flow as we possibly can when you're actually interacting in VR. And again, these are the types of challenges that seem like shouldn't exist when you are in 3D, working in 3D, because we are three-dimensional creatures that live in a 3D world. But when it comes to switching modes on the fly, that's something we know how to do with computers because we have hotkeys and we have trained our brains on how to switch between modalities quickly. But we don't have these standards for VR today or for AR. One other cool feature of this is that it works as well in augmented reality as it does in virtual reality, which is not true of things like the large workspaces that we designed because those are so big, they actually don't fit in the field of view today. Okay, so that's Editor XR, which is available for download today on GitHub. I highly recommend you take a picture of the slide and go download it. We take contributions back from the community. You can fork it and do whatever you want with it. We're actually also coming out with a runtime version so that if you want to have any of the multiple selection tools, snapping tools, 6 different types of locomotion tools, you can take them and put them in your own applications. Okay, but I also want to talk about augmented and mixed reality, which is what my team has been focused on in a large part of 2018. So this year we announced a new project called Project Mars, a mixed and augmented reality studio. Before I get started and show you pictures of what Mars is, I want to set up the problem space a little bit. How many of you are working in augmented reality right now? Okay, a lot of the room. And then how many of you are working on HoloLens or Magic Leap, like high-end HMDs that have their own sensors? Okay, so like about a third who are all somehow sitting right here. Okay. All right, so unlike virtual reality, the way that you author for augmented reality is highly dependent on what the computer knows about the world itself. One advantage to virtual reality is that, much like 3D games that exist today in movies and experiences, you know the position and location of, and what will happen to every single object that is in your space. This is the same is not true of augmented reality, which is highly dependent on working well in the real world. So in what we call partially digital worlds, all you can control is the digital. If someone opens the door, if this stair falls over, if you move a chair an inch, you don't have any control over that, and you need to make sure that your experience works just as well as if you did know that. And that is a tremendous, tremendous challenge because we're not just dealing with a small amount of variables, and we're not just dealing with unfamiliar or new hardware or different types of controllers. We are dealing with the entire world with all of its variables in and of itself. Okay, so this is what Mars looks like today, and I want to spend just a minute going over what you're looking at here. So we have what looks like the regular scene view, but it has some new properties that we've created just for Mars. So you'll see that there's that little car in space, and it's on a plane. And this is known as an AR object. And an AR object is not a digital object, exactly. And it's not a real-world physical object necessarily. Instead, it is the result of what we call a query. And a query is just looking for something. And it could be any given thing. It could be an image marker. It could be a plane of a certain size. If you have an object recognition library, it could be a chair. Whatever it is that you are looking for and you have the ability to find, that is what we call an AR object. And AR objects are the thing that allows other events to take place. So the blue plane here is just looking for a simple plane like you would with ARKit and Core. You find a plane, put the car on the plane. And this is a really basic type of AR interaction that I'm sure you've seen on your mobile phone before. And then over on the, well, right-hand side for you, or for me, we have something called the simulation mode. And the simulation mode is really, I think, the key and one of our favorite parts of Mars. The simulation mode allows you to do a few different things. First, you can test against a variety of templates that we have set up that are simulated data. That, in this case, this looks like a living room. It's a bunch of models. It'll bring back the same sort of plane information as a similar type of real-life living room. But if you had a mesh or scan of the living room, a real one, you could put it in there yourself. If you had a mesh or scan or CAD file of a building that is real, you could put that in yourself. But we know that a lot of the AR experiences, they might be designed for a specific location. That's entirely possible. But many, many more, the ones that need to work every day in every place, need to be tested against a variety of real-world locations over and over again by users who need to be standing at their desk the whole time. So what we're trying to do is close the gap between you having to make an app, put the build on your phone or your HMD, try it out, be like, that didn't work, take the headset off, go through, do another build, and so on. Instead, we want you to test against the closest thing we can have to the real world in Unity today. So that's the basics behind Mars. And I'm happy to go through more detail, too, if you would like to know more later. And here's a larger view of the simulation view. So you can see we have different types of planes highlighted. And it gives you different gizmos, ability to create conditions like proximity conditions, height requirements, elevation conditions, closeness, angle of HMD, controller information, all that kind of stuff. And this is actually something we've never shown publicly before, but I wanted to give people a little sneak peek. This is kind of a weird one-off that our intern did this summer that allows you to simulate a different space while you're in a current space. And we actually found out this is really important for testing. So it does a scan of the room with the mesh, as you would traditionally expect. But then instead of just being able to test your app against that mesh, we let you put in digital objects that pretend they're real objects. And then you can test the app against that. And the point of this is to, again, be able to just test very quickly against a whole bunch of different realistic or physical environments without having to leave your desk. We get it. Everyone is inherently kind of lazy. You don't even want to have to walk like 10 feet away to test something. You want to just be able to stand at your desk and pretend the whole thing is a bedroom. So we want to bring that to you. Okay, so now I'm going to talk a little bit more about, and I think this crowd is a pretty experienced crowd, but I want to talk a little bit more about the different ways computers are making sense of the world today. These are all the big ones. There are more, they tend to be a little bit more esoteric. So obviously camera pose is a big one, finding and detecting surfaces, hit tests, meshing. Faces obviously are really big. They're actually one of the biggest AR added inventories today is for face meshes and masks on Snap, Facebook, and so on. Relocalization, 2 and 3D markers, image markers, 3D object markers, object recognition, light estimation, body tracking, and depth information. And these are the things that you can get today in a variety of ways. For some of the very robust, high-end hardware headsets like the HoloLens, you get a lot of them baked in. Magic Leap actually has a lot, I think even more sensors than the HoloLens actually. And then some of this you can only get through third-party software providers. 60 was on the stage earlier, for example, and they do relocalization and meshing. But there's a couple of problems with this data for people who are actually trying to make augmented reality experiences. So the first, and I think like the real big one, is just that most of this stuff only works at runtime. So a lot of this is also machine learning that is designed to work with a specific hardware stack on the GPU. So they assume that the only time you'd want things like plane information or object recognition is when the app is actually running. And that's true for every consumer who's going to download your app, but it is not true for you, the developer, at the moment when you're actually trying to test and make sure that it worked. Computer vision is also pretty nascent. I mean, really, I think like you can always go back in time, like to the 70s, and find that people have been working in the problem area for years. But actual real-time on-device, on a consumer device that people can afford, like that's really, really, really new. And again, it tends to be tied to particular hardware stacks because you choose at some point if you want to go with Core ML or if you want to go with TensorFlow, and that starts you down your path. So for the future, we're hoping this becomes more ubiquitous and more consistent, but for developers today who are choosing, for example, what sort of 3D object library to use, they're probably going to use Vuforia because there are so few other options on the market. But we do think this will be big, and we want to make sure that we support it. But, okay, that brings us, that's the first new thing. This is the other new thing. The more we thought about augmented reality and how it will work and all the complications, the more we realized that almost everything about how we think about computers today and how we interact with computers today will need to be completely rethought. Upside down smiley face. And let me give some examples of what I mean. So today, email has taken on a really strong importance, especially around privacy permissions and sharing. Oftentimes, it is now used as 2FA. It's used to send someone a link. It's used to confirm that you signed up for Twitter. It's used to send all sorts of things. They're being used through email that you wouldn't necessarily expect and you probably don't even think about regularly. Sharing things across platforms is very difficult if you don't use something third-party like email. Another thing, what permissions are right now is highly tied to the individual, and I'll get more into that in a minute. But when it comes to augmented reality and a world where we're all wearing headsets, a lot of that becomes location-based, because when you're in someone's house, you have a different permission layer than if you're in a public park, right? Or if I'm standing next to you, I, in theory, might want to be able to grant you more permissions to see what I'm seeing naturally than you would expect in today's world where we're all just looking at each other's phones. Right now, you can kind of infer intended permissions because I'll take my phone and I'll point it at you and say, hey, look at this. But if we're all wearing AR headsets, that workflow doesn't work at all. We need something new. App discovery in general, right now it's not even that easy to find cool apps even with the App Store, but finding them in the future, particularly if they're like lost in your house, there has to be a new mechanism for that. Modes. So how do we define not only the states of what an app is it active, is it closed, is it minimized, where is it, but also what are you doing with it? Is it like I set this down on that table over there and now it's going to be on that table forever, or I'm going to set it down on that table but I can also access via an inventory, or maybe like I set it down but it follows me around. Like these are all new things around spatial computing that we haven't had to really think about before. We're going to have to tell computers things that we never normally articulate. Again, that goes back to permissions. I'll get into that. And then also, all of the things around modalities and inputs and controllers and how we talk to our computers will have to be rethought, and is starting to be rethought. Okay. Let's talk a little bit about this. We're going to need to tell computers things that we never normally think about or articulate today. Permissions. I touched on this before, so I'm going to I'll go a little quickly, but you'll get the idea. So we're thinking about this, and let me contextualize here too, that we're not coming up with the solutions. We want this to be a community discussion, but in order for us to move forward with the tools that we're working on today, we need to have some sort of structure of how we think people are going to want to start developing apps and the types of permissions they'll want, the types of states they'll want, and so on. So this is not the end, this is just the beginning, and if you're thinking about this, we always love to talk to you about it. Okay, so public permissions, and you always see this in sci-fi movies, and it's like creepy dystopia with lots of ads, like 2049 style. But so obviously, like it'll have to be filtered, it'll have to be pretty heavily regulated. But this is also the coolest opportunity we have as humans to really bring some of the beauty and the dreams of our imagination to life. I'm not sure if any of you saw, there's this new bridge, I think in Thailand, that's made up of gigantic hands. Has anyone seen this? It was going around the internet. Yeah. But we can be doing that with augmented reality in these public spaces and inspire people who might not otherwise have access to this kind of art. And I think that's very inspiring. I'm looking forward to that. Okay, controlled spaces. These are semi-public spaces like stores or offices or malls. These are places that usually, not always, but usually have a commercial owner. So the question is, who owns what we do in these spaces? And you might say the landowner owns it, the permission set. But of course, there's always an argument too that maybe the individual's permissions should trump any sort of commercial space. And I used to think that this was probably definitely true, that the individual always trumps any sort of permission set that you'd have in a commercialized space. But then someone pointed out if you're in a mine and there's a gigantic do not go here warning sign, that will need to trump any sort of individual's ad blocking permissions. So just a little thought exercise. It'll be a great place for holograms and 3D displays. It'll also have to be quite heavily regulated, as people will try to do weird things to break the system, especially inside branded spaces. And for IT guys who are going to have to set up all of the new 3D Skypes of the future, I don't think it's going to get any less painful, but it will eventually make the shift in the same way we've now moved to have Skype on our phones. Okay, intimate spaces. So these are personal spaces, things like apartments and homes, of course, but also things like the interior of your car or your gigantic farm or your gigantic ranch. Today we have ads in our home all the time. You have ads when you watch YouTube, you have ads when you watch anything streaming or many streaming things. And for the most part, we can kind of control when and where that happens. It's always constrained, like all computers and all digital interfaces, to this kind of bounded box, right? But when things can appear anywhere in the home, then we're probably going to have to, and this gets back to articulating things to the computer that we don't otherwise, we have to tell the ads where is the safe space in the home that they can be played. Is this something new? And we'll have to actually think about it. And more importantly, the consumer themselves will have to be deciding what they want to do with this in a way kind of akin to how they would have decided where their television was in the house now. People want to personalize their UI a lot more. The biggest computer company in the world right now is Apple, and Apple has made a lot of money not letting you personalize stuff very much. I'm still pretty bitter about how you can't change the fonts on the OS level, and that change was made like in the 90s. But people want to personalize this more, and we'll need to give them the ability to do so. And then we'll need to give them the ability to know that they can do it and how to do it in an easy-to-use way. So there's a lot of unanswered questions here, not only around how people will want to use spatial UI, but how we can create standards for how they know they can use it and what they can do with it. And obviously there's the clear boundaries, right? If you have a teenager, maybe you want to be the cool parent who lets them do whatever they want in their room. And that's fine because, again, right now a lot of computing is limited to a single sort of window or volume. But if you walk in your teenager's room and it's completely plastered in something terrible, you're probably going to want to take their permissions away from them, and that sparks a much larger discussion on what they're able to do in their own room versus what they aren't. And maybe these are discussions you're having with your kids already, but not everyone does. But having spatial computing that's ubiquitous means we'll have to have these kinds of conversations more often. And then finally, private. And one thing about this that makes it unique compared to any of the other permission sets that I talked about so far is that this is not a spatial volume. This is only tied to the individual. So every other thing that I just discussed can change the second that you cross from a boundary from here to there, but this one you take with you wherever you go. So this includes things like your email, your diaries, your password, your finances, your health information, all of the stuff that you routinely think is your own now. Again, for the most part, we assume it will be top-tier permissions, that you get to choose most of what you see and do in your digital world. It will require you to give permissions to others, hopefully not by sending them an email, which then they reply to, so you can send them Google Maps directions, but we'll see. But it also will require users to think a lot more about how they want their world to be. If they see something digital that's cool, where do they want to put it? What do they want to do with it? When do they want it to go dim? When do they want it to disappear entirely? Right now, nothing about how we use computers encourages users to customize that much. People who do so tend to be more interested in computers. But as computers become more sort of 3D native and easier to use, we can anticipate that people will want to customize them and do things with them the same way they want to with all of the rest of their physical possessions. All right, I'm going a little slow here, so I'm going to speed up. We're also talking about different types of interactivity states for apps: active, semi-active, remote, and minimized. Active is just fully active when you're fully interacting with an app. Semi-active is when, and maybe you've turned to look at an app, so it goes opaque, or it starts to become brighter, it starts to become bigger, it starts to look at you, whatever it is that it does. And this state is a transition state, but we think it's really key to making it feel like things are happening and not just slapping you in the face. Remote apps, for example, you have a Netflix screen on your wall, but you have the actual Netflix controller in front of you, so that way it doesn't take up screen real estate the way it does today when you're watching Netflix. Volume controllers, thermostats, lots of examples of different types of remote UI. And minimize. So for example, if you have the Spotify app open and it's attached to your body behind your ear, but you can't see the interface whatsoever. This is pretty typical. We actually have a minimized version of that specific interface every time your phone is put away today. But we need to be able to find things again. And so this begs the question, will we need a master inventory for all of the applications you have so that you can pull them up at any moment? I think the answer is yes. But again, this is something that we get for free with computers today because every app is just tied to your physical device. But when it comes to a spatial UI and you're just carrying around an AR headset, the paradigm is different. So we'll have to make something like that. And then finally, location. Things could be anchored to the world, like fireworks over the Eiffel Tower. They could be anchored to an object. Like, for example, I could have something attached to this controller. They can be in transition when you pick up and move them from one space to another, or they can be anchored to the user themselves. Like I have my email app open in front of me all the time. So this is the matrix that we've come up with so far and how we're thinking about augmented reality and spatial apps for the future. And a lot of this has been validated by different experiences that we've tried, especially on HMDs today. But again, we know that this is just the beginning. So if you are working on apps in the space, if you are thinking about how this could be improved, if you've come up with examples that I have not mentioned so far, we would absolutely love to hear about it because we're at that stage where we're really trying to figure out what people need in order to make a spatial computing future that really works. So we want this to work because we think it's really cool and we don't want to fuck it up. So that's why we're doing the work we're doing. All right, I have 12 seconds left. So we have some new UI types that we're also considering, display only or interactive. But the goal here overall is we are trying to build the tools so that you can build the future. And our overarching goal really is that we want to support how users want to interact with our computers. So, thank you very much.